Hey everyone, how's it going? We're going to get started with our Pytorch LSTM. Today we're going to do training. We're going to do training today. I'm really excited about this. This means that we have the ability to get our model to learn. This is the training part of the model. This is the part I'm really excited about. It took us a while to get here because we had a lot of little details that we need to learn, especially with the loss criterion that we were dealing with. That's one of the things that took us a little while to figure out. I'm going to do a couple of things really quick on my screen, and so that way you all can't see what's going on. 1 second. I'm going to make sure that everything is in the right spot. Okay, here we go. Let's close that. There we go. All right, good to go. Okay, here we go. Oh, you know what? I need to do this button real quick here. I forgot to do this. Copy, copy, copy. Let's go over here. Oh, okay, here we go. Started 30 min early. Party popper. Here we go. All right. Here we go. Okay, so let's get our data set up here. All right, so this is our tags, right? Our tags are labels, right? Labels, tags, whatever our output is going to be that we're looking for, that we're optimizing. So I wanted our mask to actually be down here. So let's update this so our mask is here. And then we are going to adjust that. So this is basically our pad, right? Our mask or our pad. What do you call this? Our out mask. Pad, mask pad. Out. And this will be number 3. Let's decrement this. Decrement. Okay. Oh, yes, indeed. We're going to overwrite that. And then we're going to go up here and we're going to add a pad here. I think we'll call this pad. This is in pad. This is our input pad. Hey, how's it going there? Christos, what are you coding? We're creating an LSTM. We're becoming Pytorch experts. This means that we are going to learn everything we possibly can with Pytorch. We already know, I already know a lot of the foundations of AI, deep learning, backpropagation, that full flow. I'm used to doing it manually myself. Now what I'm going to do is become an expert at one of the frameworks. This is going to be Pytorch. After Pytorch, we'll maybe learn JAX, and then we can compare the two. Does that sound like a good idea? Let's do this together. I want this to be 9, maybe? Is that where I'm going to give it? So yeah, so this is going to be a number 9. Why is this looking weird? Wait. That looks weird. Let's see, this would be number 9, number pad. Okay. What we should do is we should build the dictionary. I know we're planning on training the model, but what we really should do is, because since we're dynamically building this dictionary, we should have it. Nice? Yeah, all right. Good to hear it. All right, so that's the plan for today. Here's what I'm gonna do instead. So we're going to always make the last output when we're building our dictionary, one last update here, tags.update, and we're gonna add a mask. That's what we're gonna do. Hey, Dreamer! The Dreamer's here! How's it going? Welcome on in. Good to see you. Happy Wednesday. Okay, so I want to update this. It's going to be... what should we call this? This is going to be called the mask. All right, I think we're just going to call this the mask. Keep it really easy.
Undisclosed use of AI while coding.
Whoop.
Yeah, that's an actionable...
another video played. I did. That was This is Prime over here. I'd want to watch that one. I'll watch that one later. All right, I forgot to loop the audio. There we go. Loop. There we go. All right. Second like is mine. All right. Thank you, the Dreamer. Good to have you here. So we're gonna add in a mask. This is a tag mask, and it's going to be set to the length. I believe just the length of the tags. Let's try that. Let's see if that works. I think it might work. So let's get rid of the print there. We don't need any of that for now. We're just gonna load those, and we're gonna build them once. Okay. I think this will do the trick. We should also do the same thing for a dictionary. This will be dictionary update. This will be a mask length of the dictionary. Okay, that should do the trick. I think that should be fine. I think we should be good to go there. Now, let's rebuild those and print them out. Let's rebuild and print those out. So it's the dictionary and the tags. And we should be good to go. Let me disable the training and rerun it. Wait. RM and Python full. Okay. Oh, right. Because they're already gone. Sure, fine. Okay. Here we go. There we go. Okay. So our mask is 3. Yep, there it is right there. And mask is 9. Hey, programmatic solution. There we go. That's the way I like to see it. So let's see if we can get our training started now. We might finish this really fast. Bridge gap between your dream and real life is action. Only thing that fills the gap. That's the only thing that fills the gap. Quoted by the dreamer. Got to bridge those gaps. Had some interesting dreams. Had some interesting dreams last night. Some interesting dreams. What was it? We were phasing. We were our transportation. I don't know. In your dreams, do you ever have abilities or some like uncommon things happen, like things that shouldn't happen in real life? Do you ever have that? Do you guys have that? I'm curious about that. Okay. So I want to continue on this. This is actually great. This will be great. This will be nice, simple, easy to go. Do you guys ever have special powers in your dreams? Okay. I think we're good to go. Let's run it through one epoch and see if that looks good. Okay. That looks great. No errors. All right. That's good. That's good. That's good. Because we added. 1 second though. 1 second. We need to do. How are we doing this here? This part right here. Nice. It's all automatic. Okay, good. So we have our target inputs and our target outputs. Excellent. Hey, Jinlu. Handsome. Oh, well, thank you. You too. Appreciate it. Welcome on in. Happy Wednesday. We're going to get our LSTM trained today. That's what we're going to do. Return in a few. Sounds good, the dreamer. All right. Jinlu, good to have you here. All right. So we're playing your song, Jinlu. Look, right here. Hey, it's Jinlu's song, you guys. All right. Let me see. Pull this over here. Now, where are we at here? We need to understand. All right. So we get our delta. Did we print the delta? We got the delta right here, right? This is the final negative likelihood of loss. Now we can run backward on the delta to generate our gradients. We're gonna do it. Hey, Daniel, how's it going there? Daniel Hartz. Greetings, fellow human. Love watching a code wizard work. Hey, you're a hardware guy. Nice. Oh, what kind of hardware? How far do you go on the silicon side of things? Are your microprocessors very big, like larger, like things that you would see in component boards, like in vehicles? Or do you do more things like mechanical or carpentry? Sysadmin. Hey, well, there you go. So data centers, computers, 1Us, 4Us. Are 4Us even around anymore? I don't even think they do 4Us anymore, right? Thank you for the hearts, you guys. Those 4Us. And Raspberry Pi nerd. Nice. Great to hear it. Anyways, just did some soldering. Check journal. Sounds good to me. Oh, Jay Vora, thank you for subscribing. Welcome on in. Good to have you here. You joined the right channel for artificial intelligence software engineering. That's what we do. And we code everything by hand here. We code it all by hand because we want to learn things. This is a learning channel. I'm spending time here on YouTube to learn. We're learning together and I'm typing. Because if you use the AI to write all the code for you, are you learning? You're not really, maybe a little bit. Yeah, you are learning a little bit, but not enough. I want full on learning. All right, let's do this, Daniel Hartz. All right, so Jinlu, you said in general, you've got, hey, look at that, some hardware.
Here is the normal adapter. It has a green LED, as you can see. But I just took this one and replaced the LED because it was really like dark, dim on this one.
Ooh, nice.
And now if I plug this in,
I see some.
and turn it on, it's red. Very nice.
Hey, nice. Good job, Jinlu. So you did some soldering. You took the old LED out that was burnt out and not very bright, and you replaced it with the new one. Very nice. That's awesome. That's a lot of fun. I want to start doing that stuff. I want to have fun with those things. Audio is echoing. Yeah, it was. Sorry. Yeah. it won't be echoing now. I have it set up to where it will probably echo a smidge if I'm in that situation. Right now, though, it won't echo. You'll be good now. Okay. Oh, hey, Daniel Hartz, you also subscribed. Thank you. Good to have you here. Welcome on in. You're on the right channel for software engineering. Yeah, there. Just because he was listening to my audio. Yeah, exactly. I had to listen to the audio there. Yeah. So I had to bob up the audio on my side, which then got into the microphone, right? And then it echoed back because I've got desktop screen sharing as well. It's a nice one. It was good. It was a good video. All right, you guys, let's do the backward. Delta dot backward. Wait, backward, right? Is it backward or backwards? I think it's oh wait, we got to do it for each one, right? For each delta, and then we need to optimize. All right, let's try it. Let's try to do one. Oh, okay. Trying to backward through the graph a second time. No, just once. I'm doing it just once. Oh, wait, we got a zero grad. All right, let's do it here. No, wait. Do we do it right before the forward? Oh, here, okay. Here, let's see here. I want to do that. All right, let's do that here. Index and labels. Okay. All right, let's try this. Wait, is out the correct? Yes, is that its correct out? Index. Wait, no. Oh, okay, I see what's going on. All right, so since we did it in the batch, we're gonna have to do a little bit differently, right? We're gonna have to do it a smidgen differently. All right, let's undo that. Let's bring that batch back. Here we go. We have to do that here. Maybe. Let me think about it. Yeah, we can only do it once, but we get different loss criterion for each because of negative log legacy coding. And so since we're doing it through a batch, okay, we need to think this through, you guys. We need to think this through. Art the Dreamer, it happened while using OBS. So typical OBS issue. Yeah, definitely some echoing there. Okay. So let's get back into it, you guys. Just lazy excuse to do some hardware modding. Hey, always a fun time there. Okay, so I know what the problem is. If we do this once here, the problem is though that we're missing out on everything. It's all missing out. So we'd have to rerun the batch again the second time. Can we do we can do multiple. I know what we can. Well, what if we do? Okay. Maybe we do have to model. Maybe we have to zero the grads out. Okay, I've got an idea. Let's try this. Let's try it like this. All right, we should see no errors this time. Okay, just kidding. Darn it. All right. You need to solder some headers from a rotary decoder. They're angled and they need to be flat. Nice, Jinlu, nice. All right, we'll find out here. It'll be... All right, so delta backward. It should not have done that. Let's try to zero the gradient each time here. All right, so that's fine. Delta backward. It's a different delta though, and we zeroed the gradients, you guys. Is it the problem though? Is that we're only getting one output? How do we do this? This is not. I want to do it differently. I want to do it a certain way, and it's not letting me. And I know you can do this mathematically. It's just the framework is like telling me no. The framework's like, nope. You want to do the thing you wanted to do? Oh, you did? Sorry, not gonna work. Okay. Okay, let's see if there's any more details. Let's read through this error real quick. All right. Trying to backward through the graph a second time or directly access the tensors after they've already been freed. Oh, save intermediate values of the graph are freed when you call backward. So I can only call it once, even though I got the full thing. So how am I going to get the delta from the batch if the criterion... Okay, so we understand why now. We know what the problem is. We need Jarvis Friday. Oh, yeah. And from Iron Man, yep. If you know, you know. We could. It would be great, because then it would explain everything to us, right? It would explain it to us, and we'd understand why. we'd get the full picture and all the details of the reasons behind this. However, I understand it now. I just need to figure out how to deal with it. So we can only do this once, is what this is. All right, so we zero out the gradients, and then we run this here. The only problem is we're going to get multiple deltas. We're going to get multiple deltas. So how do we do this? We can only do criterion on this. All right. Break. So we don't even do that. And then I will copy this here. Let's try this. Okay. We're just gonna... It's not gonna work though, because it's the negative log likelihood does not expect it to be so, right? We figured this out yesterday. It expected a certain target size and it's not gonna work because it's too big. 3, 4, 3, 7. Is there a 4 in here? No, there's 1, 2, 3, 4, 5. There's only 5 here. Trick, ask AI that how... What? Live inside internet, generate image, then you will shock try. I have no idea what you said there. It doesn't make sense to me. I have no idea what you said. I read it verbatim and it doesn't make sense. Hey, how's it going there, Tony John? Good to see you. Welcome on in. C++ will live on and be better than Python. At least, well, yeah, it's faster, right? It's faster. It's got some memory efficiency there. At least you have memory management. Oh, yeah. That part of Python, you're not having memory management in pointers. Well, Python just takes care of it for you, right? Python is C, right? But it is you don't get to deal with all of the mechanics of memory allocation and deallocation. I know all about that. I've got technology. I've written a lot of C. I've written a lot of C before. A lot of C, you guys. Okay. Let's see here. Get the song going. Daniel, you've got great energy, my dude. Thank you, Daniel. I got some cleaning to do around the house. Gonna get the dungeon crawler, Carl, and try to slay some chores. Nice. You don't learn about code and you need more direct help. Well, Daniel, you joined the right channel. Thank you for subscribing. Appreciate it. Enjoy those chores and the dungeon crawler. Enjoy them. Got to get that cleaning going. Yep. I know what that's like. I do that too. You mean to ask AI that how AI see live inside internet? So generate that view so you will shock. I don't know. I don't get it. It's an audiobook? Oh, is it? No way. Oh, that's awesome. The Dungeon Crawler Carl? All right, let's check it out. You said Dungeon Crawler Carl is an audible. Dungeon Crawl. Yeah, listen to Dungeon Crawler Carl by Matt Zinneman. Always to your keep. Okay. Nice. I thought I was going to get any more details from it. RPG adventure. Dungeon Carl right there. There you go, Daniel. That's great. That's fantastic. All right, let's see if we can keep going. Let's see if we can keep going. The apocalypse will be something. I can't see what's going on back there. All right. So here's our tutorial. All right, how are we gonna do this? I know we diverged from the tutorial a bit, just a smidgen. I know we did. We can go back to it. It's fine though. We can do it. We don't need to do batches. I wanted to, and this approach is weird, and maybe that's why. Hey Loons, good to see you. Welcome on in. Happy Wednesday. Hot Mama, welcome on in. Hello, fellow kids. Good to see you, Hot Mama. Welcome on in. Good to have you here. All right, so what we're gonna have to do is we're gonna have to run through every sentence independently, I guess. I don't want to do it. I didn't want to. I always wanted to do the batch, but it's gonna zero out our gradients when we run backward for the first time. All the inputs on the inputs, so, or the outputs rather, right? Or the whole thing. Hey, MGK Biscuit. Wait, Biscuit? MG Biscuit. Is that how we say that right? I don't know how to say your name. Thank you for clicking the hi button. Good to have you here. Thank you for clicking that button. All right, you guys, let's keep going. Let's keep going. I really wanted to do a batch here, you guys. I did, but we're not gonna be able to. It says no. It says no. I tried every possible. There's probably a way to do it, isn't there? There is, right? Hey, for everyone, thank you for clicking the hi button. Welcome on in. Good to have you here. It's pronounced Magic Biscuit. Hey, I like that name, Magic Biscuit. All right. I got the biscuit part right. I got 50% of it right. I got 50%. Magic Biscuit, good to have you here. All right, you guys. So I really wanted this batch. I really wanted the batch because it's more efficient. It's faster. Thank you for the hundreds. Appreciate it. I can see those. This is what it looks like on my screen. Oh, you stopped. Stopped. Never mind. Yeah, 0. Okay, pull this back over here. Hey, Clips. Hey, how's it going there, Clips Merch? Hey, Steven. I'm looking to edit clips for work as a daily. Do you have any work? I do have a clips editor. His name's Kurt. You've probably seen him on the channel. C-U-R-T-T, Kurt with 2 T's. Maybe clips though. Maybe we can try it out. We can try out one and see how it goes. Maybe you do a really good job. Do you have some, hey, tell you what, the tech man, right? The tech man? What if you DM me on Discord? Send me a direct message and we can chat. We might be able, we'll do a trial run. And we'll see what the results are. Like, for example, the number of views and things like that we get from it. We'll see if it performs well. All right, so our output, this is our batch with our features, and they're like, no. All right, let's just move onward because no, I really don't want to though. I really want to keep this. This line right here is so efficient. We worked so hard to get this line. We exceeded. Done? Nice. All right, we'll check it. We'll check it after stream today. We'll check it a little bit after stream. All right, so can we do this? Is there a way that we can do it? I think no, because the model itself will lose all of its outputs and inputs, right? All right, it'll do it. It'll prevent it from working. It won't work. So let's do this. You know what? We're just gonna have to do one iteration on it. Let's do one iteration. Let's see what happens. One iteration. We'll keep it simple, keep it clean, and then we'll break just on one word, one sentence. We'll only do one sentence. Is PubNub capable of a thing like a live stream chat? Yes, it is. It sure is. Thank you for the hearts, you guys. Appreciate it. Good to have you here. You're sure right, Loons. Absolutely. It sure is. We do a lot of that. Actually, we do a lot of that already. Just for fun? Nice. Hey, you click the hi button again. Hey, every single time. I love it. Okay. So you know what? We won't see any errors this time, right? No errors this time. Not a single error, not a single error. Boom. No errors. All right, we did our backward. We did our backward. Do we have our optimizer? We have our optimizer, where's that? So we got our optim, SGD. Okay, we got our SGD. So we're going to do optim.step. So that way the model can learn. All right, we're gonna train the model. Hey, the loons, clicking that high button. I hope I can beat my high score. Yep, exactly, your high score. You got a record on that. Click the high button as many times as you possibly can. That's what it's there for, right? Otherwise, why would they let you click it so many times? It's YouTube. YouTube put it there. They're like, you should be able to click it as many times as you can. Okay, so we got that to work. However, we should probably do it the right way, I guess, right? Probably do it the right way. Fine. We're gonna use unsqueeze. Okay, so we're gonna do feature. We're gonna do this. We're gonna do out equals model features index. No, not functional. Features. Functional, and we're gonna say dot unsqueeze. That's Q-U-E-E-Z-E 1. Maybe. I need to look at that. I need to look. This time I'm counting it. It's my 5th. All right, you're counting, keeping them going. Hey, how's it going there, Ali? Ali Faley? Ali Faley, good to have you here. Thank you for clicking the hi button. Oh, loons. There we go. Number 6. That's 6 there. Before I do this, though, let's do print shape the features.shape. And then we need to do features index.shape. And then we need to do the same thing again for unsqueeze to make sure that we are in the proper, oh wait, we can't do it this way. We have to say inputs equals this. Otherwise it won't work, right? Because it's not a mutation, inputs. Boom, right there. Hey, how's it going there, Yuritsi? Yuritsi, good to see ya. Hi, welcome on in. We got Yuritsi. Yuritsi's here. Good to see ya. Oh, got Loons. It said hi again. It's 7, right? Is that 7? Oh, 1, 2, 3, 4, 5, 6, 7, maybe? Okay, let's see if we can print those out. And then we have to do inputs here. Inputs. We could do unsqueeze here. We could. Let's do it like that for now. Output in. Oh, we don't need this anymore, right? Because it's going to be label. Here, I've got an idea. Label equals labels the index like that. And their features feature sentence. Let's just do sentence. That's easier. Sentence. And then this will be features. 8's time. Number 8. There we go. Got 8 going, you guys. 8 of them. All right. Label sentence. Let's put it in the right order. And then we need to print all this stuff out. Let's just hide everything for now. We're not going to deal with all this other stuff here. No breaking necessary anymore because we're going to do this the way they wanted us to do it. And then we're going to also need this. 0 the grads. There we go. Number 9. We get number 9, you guys. All right, let's try that. Here we go. Shape is not a feature. What? List object has no feature. It's a list object? It is? No. It is? Or well, let's print features in. Yeah, let's do a break. Let's actually do a break here. Break. So we don't need to redo that over and over. So let's print features. What's going on? What is features? Here we go. Nobody can beat your broken. Yep. Nobody can beat. Yep. You got it. It is a list. Then how did we make it work before? Does it auto convert it on our forward sentences? Maybe it does. Maybe it does. I thought we needed to make it a tensor. You guys. Can I just say that the rotary encoder was kind of annoying to get working? Was it? One of the big name libraries for handling those just doesn't work on your ESP32? No way! Oh, that's rough. How did you get it to work then? If the library didn't work, did you have to do some manual... You do some manual I/O? Did you do some manual I/O on it? You just found one of the ports IDs? Just coder thing when find bug, but introduce as a feature if you know you know. That does happen. I know what you're talking about then. I know what you're talking. You just use a different library. Oh, there you go. The easy option. You just found the one that works. You could have done manual I/O technically. Yeah. You sure could have. Yep. Sometimes the dreamer, you code something. It turns out you thought it was a bug, but it's actually a feature. That can happen. Hey, Sergio. Hey, Steven. Hope you're having a great day. Cool channel. Thank you, Sergio. Appreciate it. That's so nice for you to say. Good to have you here. We're gonna train our LSTM today. I know we got like a millimeter away from training it just when we started stream, and then I'm like, oh wait, no, I want to mess around with the input data more. We keep needing to do that. We're not there yet. We're almost there. We're gonna make it work. Zergio, we're gonna make it work. The plan is today we have to, the objective, we're gonna train the LSTM. If you are correct, then Python have a vast library. Python has a lot of libraries. It sure does. You're right, lots of libraries. That's like a post request to OpenAI instead of the SDK. Exactly, Loons. Yes, exactly. you're directly accessing it without a library. You're probably using a library for the post request. Although, if you just open up the port, exchange the certs for the TLS handshake, and then you pipe over data using the cipher, encrypted your payload for your post, HTTP, you're good to go. Why, like, I still stuck at 2? Why, man? Oh, wait. Let's find out. Let's find out. Here we go. All right, you guys, let's find out. So, top chat. Let's do top fans. Here we go. Oh, yeah, Jinlu. We got Click here and the Dreamer. And then Daniel. And Clips Merge. And Magic Biscuit. Magic Biscuit, you guys. Okay. Can't stop Nightmare Munchman Chips. Oh, hey! Nighttime. I just said Nightmare. Nighttime chip. What kind of chips do you got over there? Have you tried Burn? Oh, the Rust library. Amzad. Hey, Amzad Hussain. Good to have you here. Yes, Rust in the Burn library, right? We've definitely tried it. Rusty Window. TensorFlow has so many weird dependencies on Windows. Does it really? Yeah, I'm running on our Unix-based system here, so it's a little bit straightforward. You're talking about the live stream likes. It's number 2. Oh, it's stuck at 2. Okay, got it. Understood. Oh, the Lay's and Doritos. Nice. Very nice. Those sound very tasty right now. They sound very tasty. All right, let's keep going, you guys. All right, so where are we at? This is the test. We don't need to worry about the test right now. We need to worry about this part here. So we've apparently the input for the embedding wants tokens and they do not want to be tensors. Can we make them tensors? Oh, we did make them tensors. You guys, something's weird. Something's weird. What's going on here? Hold on a second. Hey, Loons, you're over there on the purple. You're over there on the purple. Good to see ya on the purple. I am excited about that. If we get more people on the purple as well, then we can become then we can enable subscriptions. We don't have enough people on the purple for subscriptions right now. We don't. No, I'm talking about Twitch. The purple Twitch. Okay, so this is where am I printing feature? Oh, but I made it a tensor right here. I spelled it wrong. I spelled it wrong, you guys. It's Steven's spelling issues again. All right. It's because of that right there. Okay. Now we're good. Now we're good. All right. Perfect. Did we? Oh, wait. Our mask. Let's update our mask. So we get our mask is going to be the length of the dictionary. We need to update the dictionary to support a mask, which is going to be here. It needs to be the lang of the dictionary. There we go. There we go. The latency on YouTube is like 10 to 50 seconds. It's crazy. Is it really? No way! And so over there on Twitch, it's a little bit faster. We got some latency on YouTube, you guys. You have more viewers on Red, man. Yep, Red rocks. Yep, we got more viewers on Red. You got it. Good to have you guys here over on Red. We sure do. Well, because we started on Red first, right? We started on YouTube a few years earlier. And then Twitch just only somewhat recently. The background changes to some tough decisions is about to take. What are those? What are those? Yeah, it's like 10 seconds or less. A little bit. Okay, all right. I mean, it's not that bad, but you know, the music got intense. Yeah, the background music. A little about tough decisions, you guys. Tough decisions. So let me double check that this is correct. Is our dictionary, the mask should be 10. So, will it be 10? Will it be 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, the dictionary's wrong. Okay, we gotta fix the dictionary. We found a bug. The same with the mask. Do we need to do -1? We gotta do -1, that's why. Okay. When we do this, we have to say -1. -1. Like that. And then we need to update the mask here as well as a -1. See, you guys, these little things, right? Okay, now we need to delete the dictionary again, and it needs to be 1, 2, 3, 4, 5, 6. Wait, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it should be 10. Should it be 10? Or should it be 9? It should be 9 is the answer. 9 should be the answer, right? I think so. Should be 9, yes. So then when we're doing this as well here, when we're putting in the mask, we have to do -1, like that. Or we could just say dictionary mask. Let's just do that instead, right? Mask, there we go. So that way we know what's what. Now we know what's what, right? Now we know. And the same thing for the tags as well. Do we need that to do over here? Or 0, it's gonna be this. And it will be tag. There we go. There we go, you guys. Whoa. Oh, wait. We can't. Oh, no, that's fine. This is the vectorizer. Okay, we're good. Okay. You explored Open Router all day, and you can say one thing. The bring your own key is broken and only working on Gemini models for you. Oh, is it really? Oh, no. So you can Open Router only using Gemini. Okay. All right. Well, Open Router should support all of them, right? That's why it's open. It's supposed to auto-select the best option, right? Isn't that what Open Router is for? Open Router is for selecting the model based on your criteria. Either need for more advanced capability or need for optimizing on spend, right? I think that's what that is about. The Python library can have malware, yes. Dreamer, yeah, it can happen. This happened before. You're so excited for the power of Claude Mythos in your hands. It's going to happen. So what's going to happen is another frontier model is going to reach the capability of Mythos from Anthropic, like OpenAI or Google and Gemini. They're going to inch towards that, and they're going to release it. And so Mythos will need to be released at some point, right? Otherwise, Anthropic falls behind. And their SDK is broken as well. Only TypeScript is, like, seriously. Dang. Open Router needs to get their stuff together. All right, let's see if we fixed our dictionary and our tag and our masks. Let's see if we did that. So RM, there we go. Is it looking good now? The mask is incorrect. So we don't need a -1. We don't. Is it because we're rebuilding the dictionary every time? Here, I've got an idea. We're gonna have to do this. We're just gonna do this. We're gonna do this. It's not a problem. Don't worry, it's not a problem. You're nothing to see here. All right. Nah, we're just gonna do that for now. Now, okay. So now we don't need a -1 on that. Okay. I like not having a -1 because it's a lot cleaner. It's a lot cleaner, you guys. I thought we did that. I was pretty sure. I'm pretty sure we got it right the first time. You only use them for free models. Oh, good idea. Good idea. That's a good idea, Loons. You just posted something today. You also posted something today you built today in general. If you want to check it out, we'll check it out, yeah. Do you ever train models with structured latent representation? Non-natural languages. Rusty window? I don't think I've ever done that before. I don't think I've ever done that. You said structured latent representations. What does that mean? Let's figure out what that means. I don't fully know what that means. All right. Structured latent representation. Help me, Google. Okay. A structured latent representation is a learned, compressed model of data that deliberately imposes geometric, topographical, or algebraic constraints to mirror real-world structures. Unlike standard structured latent, where variables are simply a list of numbers, a structured space organizes these variables to align with meaningful semantics, such as physical location, symmetry, or specific objects. Is this like an embedding? Is this like an embedding? It sounds like an embedding to me. I think it might be an embedding. The fact that NVIDIA has enough power to hack into any enterprise with Mythos, it's insane. Well, it's Anthropic, right? It's an Anthropic. And that is, they can uncover vulnerabilities. And they need the source code to do it, for the most part. I suppose what they could also do is pen test the known entryways, right? They could do that too. And they did say they did that. I think, though, when they're saying they are finding vulnerabilities, it's mostly in source code. Look at link share in Discord. All right, we got some Discord moments here, you guys. Sounds like an embedding, but reverse. What? Reverse of embedding? Are you serious, Rusty Window? That's what that means? All right. I'm not familiar with this concept. I feel like we will learn it over time, though. I feel like we will learn it over time. All right, we're going to do a quick little Discord adventure, you guys. Oh, neat. You've got a switch, sort of a, what do you call that? A gradient switch? No, it's something. It's not a gradient. It's what do you call this? What do you call this dial? What is a dial? Because, you know, it increases or decreases. I forgot what you call that. A knob. Yes. Okay. A knob. Perfect. Knob. Yes. Yes. A knob. That counts. I count it. That counts. Rotary encoder. Oh, right. That's what you were talking about. A rotary encoder, aka a knob. Yeah. Knob. You got it. We got the knob. All right. Link share. Let's do a link share real quick. You made a useless bugged AI. All right. Loons 404 flash colors. All right. We're going to try it. We're going to try it out. Oh, this is actually pretty neat. Look at this, you guys. Welcome. I'll help you badly.
Welcome. I'll help you badly. It's my art.
Okay. Okay. You said it's your art to help badly. Okay. Help me learn what? What do we call this? Let's give it a challenge here. What this is. Structured latent representation. All right, let's type that in. What? Structured latent representation. All right. Help me learn that. Let's see if it works, you guys. Let's see if it works. Hey, Mark Lemon, welcome on in. Thank you for clicking the hi button. It adjusts the volume via a serial connection between the ESP32 and your PC. You did? Nice. That's really awesome. You got to communicate with your PC. It's using Gemini and 11 Labs for the voice. Nice.
Structured latent representation. C'est un truc avec des mots. Et c'est latent. Voilà. Cherche sur Google si t'es vraiment curieux. J'ai pas que ça
I think
à
it's
faire.
telling me to Google it. Is that what you're doing over there? It's telling me to Google it? English. Race. Thank you. Yeah, whatever. You're welcome.
Yeah, whatever. You're welcome.
Okay. All right. That was neat. All right. Loons, you got it. You got it. Good job. You made it work. He's not supposed to respond in French. Oh, well, he sure did that time. Sure did that time. Mark Lemon, good to have you here. All right, let's continue onward. All right, where are we at in our code here? So we had a problem. So now we've got the correct. Yeah, we got everything correct. And the mask is showing up properly now. Yep, the mask is padded correctly. Nice. Okay, we're good to go now. We're good to go. Ask if it knows Stephen Blum. All right, let's try it. Let's try it. Do you know, let's see, know Stephen Blum? Question mark. Blum is, yes. Blum, yeah. Who is that? Oh, just, continue. Is it being truncated? It seems like it's being truncated. Is it intentionally ending after a few tokens? I think it's truncated. No, it's just okay. All right. Okay. We got our answer. It might be able to know. It might be able to know. However, it's not. As far as we understand, it's not. Okay. So we got our mask. We're good now. Everything looks correct. Everything looks correct and nice and easy. It would be nice to print out our tags as well. Yeah, it's right here. Tags. Let's print out our... After we vectorize. After we vectorize, I'm going to print these guys out. Let's print features and print labels. All right. You agree with the name? Oh, do you? It's a yep, there you go, right? The name of the AI, it works only until it mostly doesn't. It mostly doesn't work. All right, so that's what I was looking for. Yeah, that's what I want, I think. Yep, let me double check the labels. 3 for the mask, is that correct? Let me think, the mask on the labels, I feel that looks wrong. So let me take a look here. Back. Because there's only 0, it should be 0. And there's no zeros. So it's off by 1. So why is it off by 1? What's causing it to be off by 1? So when we build our tags, all that looks correct. So our tags here, this is correct here. Rusty window, is this a browser model? Oh, well, this is Pytorch right now. Oh, this. You mean this? Where'd that go? I don't know. Let's find out. Let's look here. Let's find out. Send message. Click send message. Where's that at? Send message is here. Okay. Context window. Fetch await / chat. We don't know. We don't know. There's a backend it's obscuring, but so it's not a browser model. It's something on the remote server because you can see there's a / chat. Right? So if we open up our window here and say, hello, we can look at the network and we'll see this chat here that says hello. And then we go to response preview. It says, buongiorno, ribongiorno. So it's in French again, right? It's in French.
Rebonjour.
Rebonjour. There's more about the AI on the Discord. Oh. Here we go. The system prompt, you're a bad AI. You're the most useless, lazy, unreliable AI that has ever existed. You hate answering questions. Your responses are short, vague, condescending, or completely off topic. You are never helpful. You never actually explain anything. You react to the user's language, French or English, by being unbearable at that. Unbearable in that same language. Okay, so it's supposed to be whatever language you're using. However, it seems to be random. It's following your instructions, honestly, right? It really is. It's following your instructions. It's a thing with letters. Good luck. I like your examples. You never refuse to answer, you just answer badly. Yeah, all right, that's great. You've DM'd me, by the way. I'm asleep, it's good. All right, clips clips, yes. All right, clips merged, the tech man. We will check the Discord after the... See, I see your message here. I see it right here. We'll check it later after stream. Also, if you run out of credits, I'm flat broke. Jim and I cuts me off. Come back when our creator has topped me off with the credit card.
Sorry, I'm broke. My creator ran out of 11 labs credits. Come back later.
Nice. So you've got a backup plan. That's awesome. All right, let's get back to our training, you guys. The goal for today, we have to get this working. We have to. We're so close. There's almost nothing left to do here. The thing is, our tags and our outputs are broken, and maybe the same thing with our dictionary, because I'm not seeing any zeros. See, I'm not seeing any determinants. And we should see a determinant, and we don't see a single one, right? Because our determinant would be here. All should be, and they all are, oh no, maybe they are 9. Are they? No, they're set to mask. The determinant should be 0 because we're looking at the dictionary right here. So we should see zeros, not 9s. Why are we seeing 9s? It didn't make any sense. It does. This part's working, but the determinant. Oh, I think I know why. Hold on. I might have a short circuit. Okay. This resolves to 0. And because it resolves to 0, it's turning into a mask. Which might be okay because the determinant has no meaning whatsoever. However, I understand it. And the same thing is happening as well for our tags. So it's not getting a 0. Create Claude Mythos, no mistakes. Exactly, Rusty Winnow. That's the way to do it. Just have the AI create it for you. Just have it automatically. Automatic easy mode. Automatic easy mode. All right, so I am very much interested in... Let's think this through. So we've got a challenge right here where we've got additional input data that is getting short-circuited right here. And that's a problem. So how do we go about this? It's because the output is 0, but it's correct. We just need to... What if we instead made it into a string? And this is like wasteful. It's totally wasteful. Like we could turn it into a string and then convert it afterwards back into a number. Mythos versus Jarvis. Well, technically Jarvis wins, right? I think right now Jarvis is like what is it called? A super artificial intelligence, right? Artificial super intelligence, so ASI, right? That's Jarvis. Beyond what a human can do. Mythos isn't quite even at AGI. Hey, Anasazi, welcome on in. Good to see ya. Happy Wednesday. We're really close. I just need to figure out how I'm going to deal with these things here because in our short circuit, which we're using this sort of like a ternary here, it's broken because I need it to return 0, not 9. How do we want to do that? I suppose we could just invert it. We could put the mask at the very beginning. Right? We can make the mask 0. Let's just do that. That's easier. All right, we figured it out. We figured it out, you guys. We figured it out. The mask is going to be 0. Here we go. There we go. Mask at the top. Mask at the top. There we go. Much better. Much, much better. And then we just set this to 0. Like that. Cleaner, cleaner, much, much cleaner. Okay. So let's try running this again. Nice. There we go. And we got our masks. Yep, we got our masks there. Looking good now. We're good on our masks. Look at that right there. Happy, happy. And then we've got our labels with our masks and our labels. Perfect. That is clean. That is very clean. We figured it out. We figured it out. All right, this is great. Okay. So now we can start training. I think so. I think we can start training. Let's do it. We're almost at it. We're almost at it. Do we need to unsqueeze here? I think we need to unsqueeze. We need to unsqueeze. So let's go ahead and do our unsqueezing here. And I'm going to do it differently. Hold on. Python import torch. Let's say a equals torch.tensor. And we'll say 1, 2. All right, a dot unsqueeze, squeeze. And we need to say 0. Yeah, unsqueeze 0. We need to unsqueeze 1. Yeah, unsqueeze 0. Okay. So we need to unsqueeze 0 on this. I think unsqueeze 0. Are we using this somewhere else? Yeah, we are right there. What's going on here? Why are we using that here? Oh, we don't need to anymore. Okay. Okay, there we go. Hey, Kyle, good to see you. Welcome on in. Happy Wednesday. Mythos versus Jarvis. Yeah, Jarvis is going to win. Jarvis will win. Anasazi, you built a new AI. I did something. You finished our Ario. Hey, nice. You stayed up all the past 3 days writing it in NIM, the NIM programming language. Words don't express. It's fast, 5 minutes, full build with twin 99 GBS. Was 9 and I stayed at it. Anasazi, it sounds like you got something pretty impressive there. What's the coolest thing about low latency to you? It's like magic. Low latency is magic. So what you can do is if you're interacting somewhere in space, say, like, for example, on your phone, you're interacting on your phone here, and then whatever you're interacting with on your phone is represented somewhere else on another device, and it looks like it's instantaneous, it's magic. It's magic. That's my answer to you. It's magic, you guys. Man, it was ResNet again. So you ignore the new one? Get the ResNet, you guys, the ResNet. You're starting to merge all of your important features and feeling better about the overall code base. Kyle, it's great. Trying to avoid the spaghetti. I know what you mean. You got to keep that code clean. I know what you mean. I feel ya. It's a craft. It's an art. Even if the AI is painting it for you, you still need to guide it. Did we unsqueeze it properly? All right, so we're going to unsqueeze there, and we need to unsqueeze again. Out equals unsqueeze. We have to do this, and we're going to do wait. I have a better idea. We're going to keep that around for a smidge. Unsqueeze 0. Do we need to unsqueeze it a second time? Maybe. We'll find out. It's open source now on your GitLab? Oh, nice! Loons, that's fantastic. Applied science and engineering is literally the empirically verified witchcraft. It is Bonzupi, you're right. Hey, welcome on in, Bonzupi. Good to have you here. Code stability equals emotional stability. It does, right? Because you need to know that it's fine. You need to know it's fine. Ibrahim. Hey, Ibrahim. I left you. I saw your comments. I replied to your comments. I replied to them in a voice note. We're gonna get our AI to train today. Did you say, Loons, that you shared your GitHub link? You did. Okay. Let's take a quick look here. Let's see here. Voice TTS main. Let's see here. Gemini. So we're using Gemini. That's what we're doing. We got some Gemini going there. Steven, do you own a tech company? Yes, Ibrahim, I sure do. For those of you who are new here, my name is Steven Blum, CTO at PubNub. Started this company many years ago, a decade and a half about. We raised a lot of money. We have over 1 billion devices on our network. That's what these things are here. Devices like mobile phones. And I've got distributed compute patents that patent the ability for communication across a cloud infrastructure. Been in tech for many years. And yeah, so I stream on the daily. So one of the common questions is like, how do you find time to stream? Well, I like to learn new things. And so while I'm learning new things, I figured I'd do that while I'm on stream. What does PubNub do? And do you personally make a lot? Oh, you're asking personal questions. All right, so PubNub, where are we at here? Let's go here. So we offer APIs for communication and everything around it. So connectivity, is the device online? What was sent previously when it was communicating the device? How do we audit that device? Security. What if we need to mutate that data before it's being sent to the device? We provide this entire ecosystem of storage, retrieval, and delivery of real-time messages for guarantees. We guarantee it, you guys. This allows you to build things like transportation, delivery, logistics. And you're seeing the car on the map move around, right? That's coming through us. You're seeing that update through us. When you're playing games, multi-sports and media, when you're seeing like live chat, right? Gaming, when you have multiplayers and you're playing in the same arena. Telemedicine, when you're talking to your doctor over your phone. That's what we do. That's what we do, you guys. Good evening, Stephen. Abdurasul, good to have you here. You're late, no worries. You're participating in a startup and had to finish some work before joining the stream. Oh, that's great. Hope you're doing good over there. Can you cite some company that work with PubNub? Yes. Here you go. Logitech, Autodesk, American Cancer Society, Yelp, DAZN. Those are pretty good ones. We got Scopely. Yep, we got Scopely. So if you've ever played, what do you call that? Like Pokemon, DocuSign, Gcash, TalkShop Live, Swiggy. So if you ordered food or anything like that. Let's see. How does one consider when they should or shouldn't use PubNub? Anytime that you have the need to communicate between users. When you have two users, when you want two users in your app to communicate, that's when you use PubNub. Because the use cases are vast. I know, right? It's just whenever you need two users, when you need multiple user experiences in your app. Right? Sorry for the personal question. Tracking car movement on the map, what would that require? So you'll have an app on the phone that captures GPS coordinates, and it transmits those coordinates over my network on PubNub. There's another phone pops in that's able to see your coordinates, your GPS coordinates, and it shows up on the map. Really easy. Monopoly Go, yeah, you're right. And Pokemon Go, yep, exactly. There you go. You know it. So you've used my technology, have ya? Like buyers and sellers. Hey, here you go, Kyle. Round one, Jarvis versus Mythos. Jarvis, Ultron. Well, Ultron's got like capabilities. All friends are so like all three winners. Oh, they're all friends. Okay, got it. Are you yourself? Oh, Ibrahim asking personal questions, are we? Asking personal questions there. I'm a little bit of an expert in Scopely games. Are you, Loons? No way! That's crazy! What do you think is the coolest part of the Pytorch LSTM code so far that you learned? The long short term. Ibrahim, no worries. You're good. You're good. You're good. It's okay. I understand. You're always curious. You're always curious. Gotta ask those questions. My favorite part from the LSTM experience is the negative likelihood loss. Right here. The optimizer, or the loss function when we're calculating the delta between our outputs and our targets. Dude, he works at his own tech company. Obviously well off. I know, right? You don't exactly. You're asking obvious questions. Hey, Hendrix, bro, it's me again, bro. How do you do your captions? How do the captions work? All right. So, I've got that here. So, Google for Twitch TV OBS subtitles. You'll find my repository here, which works on YouTube. It works on Zoom. It works on any platform. Zergio, nice. Thank you. Yeah, absolutely. Do you ever get hallucinations in all of the AIs you use with your teams? We do. However, we've got checks. We check it. We just go through checks. We go through multiple rounds of checks. Are you annoyed at how big your... oh, yeah. Oh, I see what you said there. Rewind. sorry, you said there. We've had orthodontics work. We had. So it's happened. It's happened. I want to set up a tech company too. Obviously, it's hard. What advice would you give? So you want to get to an MVP as quickly as possible. 2 weeks. You need to target a problem that you can sell in the industry. Target a problem that you can sell in the industry. Find that problem. Spend 2 weeks building the prototype, the MVP, and then start looking for consumers of your product immediately. Get feedback. Get user feedback. And then iterate. Iterate on your product. Make it better and better. Get more users. Start iterating more. More users. Iterate. Right? So you do have to release to the public. So you need to acquire users during this process. And then after you've done that, you're able to continue to evolve your product and make it better and better and better. At that point, you'll start wanting to scale it up. And you want to start adding a monetization model. Chat is being weird since I've been here. Yeah, I know. Like, who cares about that stuff? I know, right, Kyle? So, for example, a booking system for low-level barbers. Oh, and salons on a monthly membership. Yes, exactly. That's a good one. That's a really good one. You know what? That's a really good one. So here, let's go back to the subtitles. So they work, so you install them easily on your browser. So you get them to run on your browser. You click allow use microphone, right? And you say, select your microphone. And then you copy this URL and you put it into OBS. You keep the browser window open while OBS is open. So for example, I have it here. You can see right here. Okay. So, that's how that works. Then you're good to go. And it works in any language. You can specify your language settings, and you can have different formats and designs, right? And so I give you a template here that shows you a single word at a time. You love that the PubNub SDKs are open source. Isn't that great? Yeah, that was one of the things that we did many years ago. We're like, we have to open source these things. People are going to consume them. They're going to edit them. They need to modify them. They need to make them work in their environment, right? So we should open source them. I think I understand. They have no clue what you're doing, and it makes them feel intellectually inferior, so they lash out. Oh, maybe. I don't know. I don't know. I'm not, yeah, I never even thought about it, Kyle. I didn't even think about it. I'm just rolling with it. Country-wise, I am in, we'll say Seattle, USA. There you go. Seattle, Washington. Oh, wow. Oh, interesting. Oh, that's what that is. Okay. I finally figured something out on YouTube, you guys. Check this out. I don't know if you've noticed. So there's this like little symbol here. It looks like kanji. What it means is translation. So this is my original text, and it translated it, and it added commas. Did you see that right there? Isn't that neat? It's got built-in translations. Automatic translations. I finally figured out what that meant. That's pretty impressive. All right, thank you for the party poppers, and thank you for the hundreds, guys. I appreciate it. Good to have you here. All right, you created your version of 0, and it works in OBS, but you have a voice taking issue, like sometime it do not take accurate voice, but latency is same as your one. Oh, got it. Yes. Okay, so you've got a similar screen view. Got it. For the subtitles. All right. So let's get back to our code, you guys. We're really close. So yeah, negative likelihood, log likelihood loss is my favorite. It's neat. It's neat in what it does. It takes care of a lot of things. I was trying to do a lot of manual tuning with it, and I'm like, oh, I need to make it exactly like this. And so I was manipulating my target data, my labels, to match what I was expecting it to be, but a negative likelihood loss, it didn't want that. It will do it for you. It's like, no, I'll do it. I'll do it for you. So that was my favorite learning so far. It's been extensively trained to analyze user validation, and I think sometimes bleeds into your thought process. Oh yeah, all good. It's fun to think about that. It's fun. It's also the thought process and whatnot. Okay, so we did unsqueeze. We confirmed unsqueeze is what we wanted. So we unsqueezed it here, rather than doing this weird thing. Maybe. So let's do this. Let's do this. I want to see what this looks like. So we need to print this out like this. And then I want to also print this out. Yep. Okay, perfect. BG song name, please. Sure. The background music song, where we are. It's called Away Patrick, something like that. Here, I'll zoom in on that. Patricios. Away Patrick Patricios. Hey, how's it going there? Ben P, welcome on in. Good to have you here. Happy Wednesday. Hi, good to have you here. Currently learning JavaScript for web development. Have you ever dabbled in it yourself? I sure have, Ibrahim. I consider myself a JavaScript expert on the web because I've been doing it. It is the major part of my professional career. Anasazi, it's a push-button training AI. Send messages to the training. The AI trains itself, scraping 2,000 messages with GPT-5.4 or any of the other intelligent updates, and get action. Dreamer, you're welcome. Anasazi, it sounds pretty impressive what you got there. Your app is mostly JavaScript. Yeah, got the web-based JavaScript. I love it. That's my favorite. Because it's cross-platform. It's a lot easy. It's flexible. All right, let's run our thing here. Okay. We didn't do a forward yet. We got to do a forward. Okay. Let's see if we can do a forward. Unsqueeze, out equals unsqueeze. Yes. And we're doing L1. We did LSTM. Yes, we did LSTM here. Okay, good. Here. I'm going to print this here. The only thing is, I need this to be up here. Right there. There we go. What is that? Oh, Ishwar, thank you for subscribing. Welcome on in. You joined the right channel for software engineering. Good to have you here. Happy Wednesday. We're going to learn how to become Pytorch experts, you guys. You'd love to super focus on your very simple, clean, single function tools. Yeah, those would be great projects to work on. This looks interesting. What's going on? Hi, buddy. Hey, it's good to see you. I'm new to your channel. Okay, I'll introduce myself. Here you go. My name is Stephen Blum, CTO at PubNub. Started this company many years ago. We raised a lot of money. We're at Series E. We've got 1 billion devices on my network today. It's called PubNub. We're communication APIs for the internet. We get a lot of patents from distributed computing patents. This is my company here. It's called PubNub. We deliver live interactive experiences that your users are looking for call centers, chat, live chat, transportation, logistics, and delivery. It's those sorts of things. Gaming, multi-user experiences. That's who I am. And we've been doing this for a long time. I'm old, you guys. I'm in my 40s. Really old now. Good to have you here. You're trying to land placement currently, first year of software engineering. Any advice on how I can make myself more employable? Yes. Building an app and getting users is the best way to become more employable because it puts you ahead of everyone else because not everyone does that. So you need to build an app and then get users on that app and have those users using your app every day. That's one of the best ways to do it. You work for a company called Ice Cream Apps. Oh, you did? And that was their model. Creating one tool that do advanced tasks and all you need for code will download new files. It sounds so simple. There you go. Chill dude, nice vibe. Hey, thank you, appreciate it. Good to have you here. We're going to be learning some Pytorch today. That's what we're doing right now. We're going to make sure everything is in the right shape and we're going to train the model. That's the goal. That's like we have to do it today. Today is the day. You only ask because you work in industry. Hope you don't mind. Absolutely, yeah. Ibrahim, that's the best way to do it. You got to build an app and get users and make sure those users are using your app. Because not everyone does that. Taking it to that level is one step above where everyone else usually goes. Also, if you're targeting a specific company to join, make sure to use their product. Become a user of their product. Before you apply, say, hey, I've been a user of your product. I'm using your product. Whatever it is, it could be an API. For the case of PubNub, for example, you can go to our website and click on Get Started, right? Sign up, get your API keys, and start using our API, right? That's one way to do it. You can use it for any company. Just make sure to use their product. That'll bring you up a level as well. There's 2 good tips for you. Got 2 good tips. My brother would love you, and he's in his final year in bachelor's degree. Nice, computer applications. Currently specializing in artificial intelligence and machine learning. That's what we're doing here. Good to guys. And we're going to make it work. What exactly is an API? Oh, well, it's the ability to fetch or submit commands to remote systems, right? What is an API? Well, an application programming interface. That's what it stands for, right? API. You'll typically run into these APIs when you're trying to access other people's systems. You'll interface through an API. You'll fetch things like sending email address, right? Sending an email or sending a message, some sort of data, retrieving data, downloading data, right? There you go. Those are some APIs. The NIM language is best for all. NIM is great. I really like it. It's great for uploading all the clouds. It fits on your phone. It performs and it does video too. Anasazi, you're a NIM fan. NIM fan. Unfortunately, can't join the stream. Your biggest weakness, not knowing English. Oh, yeah, got it. We're using the translator. Understood. I was wondering. We should get a live translator. The only thing is there's so many languages, we can only have so many translators on the screen at once. Sentences you have read and understand them through the translator. Couldn't manage to translate English into your native language. Ah, Uzbek. Can you look up ice cream apps? Yes, let's do it. Ice cream apps. Is this right? Cool software for everyday needs. Enjoy the best and easy on-screen recording, video editing, photo editing. Work. Get all ice cream desktop apps with 80% discount. Oh, nice. Okay. Looks interesting. Oh, nice. Okay. So it gives you a whole bunch of apps that you can use. Like a video editor. Nice. Okay. I mean, I can say it's nice. There you go. I can say it's nice. It looks good. And it's well designed. Like, it's beautiful. It's very nice. Where's our code at? Here we go. Good luck getting the API key. That's the, oh yeah, you got to get those API keys. How is PubNub working? Like, when does it know to pull the new message? So what we do is we establish an outbound connection through a broker. It's nearby where you live. The broker is near where you live. And we guarantee data delivery through the broker. It allows you to listen for incoming messages. That's called the subscribe. So you say pubnub.subscribe. That'll open up your connection to a channel. You name the channel whatever you want. And then somewhere else you can say pubnub.publish. So let's go through a tutorial real quick. See, developer tour, JavaScript. Go to the next phase here. Okay. So see how we can subscribe here? So you open up a connection, you say pubnub.subscribe, which subscribes to a channel. And then you can send a message to that channel by publishing it. You publish it, and then you can see what the message is. It pops up over there. And that can be done anywhere in the world. There you go. Thank you for the reactions, you guys. And that's how you get messages. And so you can publish and subscribe from any device on the planet, and it does not matter where you are, and it will get there. It'll get there. Isn't that neat? That's pretty neat. So that's publish, subscribe for you right there. Publish and subscribe. Translation is a huge area to develop from the chat. It sure is. Thank you for all the reactions, you guys. Appreciate it. It's almost instant. It is. It's almost instant. Exactly. That's what the subtitles are also powered by. They're powered through my technology as well. That's why they're so fast. Thank you for all the party poppers, you guys. Let me catch up on chat here real quick. All right, so you're saying 0 here. Let's see what you say. Saying is an example of building small single function tools and expanding a company like their architecture. Yes, ice cream apps, got it. It's like that. It is. You like the UI on Asazi? It's pretty nice, good UI. I didn't even know what was happening, but it's intriguing. Hey, all right. Well, glad you're intrigued. Almost instant. Yeah, exactly, Loons. Yep, exactly. Isn't that neat? Really? Yes, really. For real. For really, really. Thank you for Rusty Windows. Dang, you patented that. Yeah, I sure did. I sure patented it. Got those patents, you guys. You can see the real patents too, so you can do Google patent search. What did you invent? Communication. It's a pattern of communication in a distributed compute fashion that allows you to have billions of connected devices and getting latencies at, you know, millisecond latency level. It's really great. Patents, damn, I know, right? The subtitles feel instant. They are feeling instant, aren't they? They are pretty instant. Okay. That's why we have them on there. Because it's impressive. I think it's impressive. All right, what are we on our time? Okay, so we do have a limited amount of time that we do need to make sure. Did you make those subtitles? Yes, I sure did. There's open source right here. You can get them anytime you want. Anytime you want, for free. I'll put this in our Discord again, because usually it comes up often, so that's why I have there. I'll throw it into the link share. Here you go. There you go. In our link share. Right there. I'll hide that right there. There we go. So we don't move loons. Let's see. You don't connect? Oh, meet you tomorrow. Sounds good, the Dreamer. Good to have you here. Don't any connection with this tech thing. You don't know anything about anything. No, hey, you're all good. You're all good. You just take a little time to learn. It just takes a bit of time. Do you have a link to join your Discord? Yes, I do, Ibrahim. Let's do that. Just for you. Copy. We're copying it. Wait. Invite friends. Okay. Oh, wait. Is it going to work? Here, let's try this. Here we go. Copy. There we go. All right. At Ibrahim. See if we can get that in there. There we go, Ibrahim. Just for you, since you're asking for it. That's just for you. Okay. Let's get back to our technology here, because we got to get this going. Okay. Is this going to work? I need to run it through the forward. Can we just do a test? Let's do a test. Make sure that works. Input size, -1 must be equal to the input size. 12 got 6. All right, let's see here. Oh, those shapes look different to me, don't they? They're a little bit different. So what's different about this? Are they though? Are they? They might not be. We're going to find out. Okay. They look the same. Oh, no, they're not the same. Oh, no, they are the same. These two things are the same, right? 1, 2, 3. 1, 2, 3. They are identical. It's just one looks weird and the other one doesn't. I don't know why. Yeah, out.squeeze looks like this. And then out.view, which changed the shape, it does the same thing. It's exactly the same. No, it's not the same. It's not the same. It adds... Okay, it batches internally. That's why it's different. Okay. You live stream daily? I sure do. Monday through Friday. We're going to try to do 12:30 every day. We're going to try to go live around 12:30 every day. I'm trying to adjust my schedule so I can do that. Around 12:30 every day. Around that time. 12:30 Pacific Daylight Time. Daylight Savings Time. Okay, so our unsqueeze needs to be modified. I think we need to say unsqueeze 1. Let's try that. Say unsqueeze 1. Where's that? Question mark. Unsqueeze. Here we go. There's go. Unsqueeze 1. Okay, let's try this. Increment. Increment. There we go. Increment. Perfect. Okay. See if that does the trick. All right. Still no. It looks good now. Let's just double check. 1, 2, 3. Yep. It looks good now. Now it looks the same. It looks the same now. So that is identical here and here, right? 127, 125, 4746, 0655, 1613, 2699, 0403. Yeah, that looks good to me. It looks fine. Why doesn't it like it, you guys? Why doesn't it like it? It should like it. Let's try this. We'll just return out. Okay. Nope, doesn't like it? Okay. What if we do this? Like that. Is it gonna like it now? it doesn't even like it then. Okay. Oh, I know why. Oh, because, okay. It's because we're testing it. And we didn't update the test. Won't let me click on the link since I'm on your phone. Oh no, Ibrahim! It's also in our link tree. Yes, Ibrahim. Also check YouTube link tree. It's there as well. Okay, you're changing the outputs, right? Yes, we are. We're changing the outputs. And the problem is that the inputs that we're putting in here in the sentence layer, whoops, over here, the inputs from the sentences, they are in our training section, which is down here. Our test to train is a batch, and it doesn't want the batch because we're reverting. That's what unsqueezing is. Unsqueezing is adding a dimension. So it allows you to pop. So this is unsqueezing. Python. Let's do this real quick. So this is A equals an array like this, right? And you say you can unsqueeze A by adding a dimension. So B equals like this. It'd be, this is an unsqueezed A, right? There you go. So you can see the difference. So B is an unsqueezed version of A. But this also works, like C is also an unsqueezed version, right? You could do this, 1, 2. So that's also an unsqueezed. It depends on what dimension you're unsqueezing, essentially. You're essentially adding brackets around it is all you're doing. Yes, exactly. All these fancy words, and it's such a simple thing. I know, right? Isn't that crazy? Computer science, you guys. Okay, so we're not going to test anymore. We're just going to get rid of this test because, or, actually that should work, shouldn't it? Yes, it should. Yes, it should. All right, let's try it. Let's do our test training here. Oh, you joined the Discord? Nice, Ibrahim! Welcome on in. Good to have you here in the Discord. All right, so I very much want to get this working. Where is it failing? Is it failing here? Okay, so it's failing here. Because we do need to unsqueeze it on 1. Now it should work. No, not even then? 0? I'm pretty sure it's got to be unsqueezed 1. Although it could be 0. Because we're passing it in. Let's double check that everything looks right. That is still the sentences. No, that's from the embedding. So you turn the whole words into numbers, embedding. Yes, batch them, and then change the shape outputs to unsqueeze. That's pretty much it. That's it. That's it right now. You got it. You got it. And so what we're doing right now, though, is we need to get them in the right, because I did a bunch of work to get them to be in batch format. However, the negative log likelihood loss is not expecting batches, which is a problem. So in order for me to train the model, I can't submit an actual batch. We can only submit words, which technically is a batch in a way. It technically is a batch of words, and we're gonna classify those words is what we're doing. You don't have an industry context network-wise? And is networking important? I mean, it depends, right? NIM system and autopilot app factory fits in your phone will replace Ario. Will it? NIM is pretty great. You want to show it like on your screen, like AI.built from start to app in autopilot. What you using? I'm just using regular text editor right now. Just a normal text editor, you guys. All right. So where is our problem? Our problem's here. And then let me double check our input real quick. So we get our features and labels. And then we need to features and labels need to become a tensor. So let's do that really quick. Okay, feature and labels a tensor. And then we're going to grab the first sentence, print features, return. Let's get our debug going on here. Okay, so that's it right there. Is that looks wrong? No, that's fine. Okay. So here's our first sentence. Okay. Yep, there we go. And then we need to unsqueeze that. Perfect. So that right there, should we get the model out? Let's see here. And it's still gonna give me an error. Still gonna give me an error. Because of this right here. So let me see what 0 looks like. And let's see this. And then we're just going to return out before we even go into it so we don't see the error. Okay. So, do we even need to unsqueeze? I think we still need to unsqueeze it. Okay. So those are similar. The only thing is unsqueeze 0 is not going to match this view. Let's try this. See if that does any difference. No, still not good? Okay. We had it working before in the batch, so now we need to make sure that it's a 3D tensor on the input to the LSTM. It has to be a 3D tensor. So let's look at our shapes. Alright, our shape is interesting. 176 versus 716. So we need to unsqueeze 1. Okay. So now our shapes are the right size, right? They match. And this is only a 2D tensor though. No, this is actually a 3D tensor because we're seeing three dimensions here. So what is this? What is being printed out here? What are we printing out? Shape, return out. We're printing. Oh, here's the oh, I see. Oh, you guys, you're supposed to say, Steven, look right there. Right here's the problem. You gotta unsqueeze before then. You're like, right here, you guys. Okay. So this is the problem right here. Unsqueeze. Although, that is the LSTM and it's working fine there, right? It's not giving me an error. So why is it... So we need to do that, right? So this is all. Double check here. Okay, so that is a floating point numbers, right? Oh, you gotta get those floating point numbers. You got it. There's so many different floating point numbers here. Okay. So I think we're on the right track now. So we need to unsqueeze this right here. Let's try that. No errors, right? No errors? No errors. There we go. No errors. All right. All right, so now we need to do the same thing here. And we should be good to go. Right? No errors. No errors. Yeah, there we go. There we go. Okay, perfect. I'm going to delete everything. I don't care anymore. I don't care. Gone. We don't need it. Okay. So this is our results. Perfect. You don't see where the batch happens? We had to unravel the batch. The batching was going to happen here. So what I did was in our vectorize, it's going to create all of our training data. It's going to vectorize it and convert it into numbers. Right? These numbers here, which is our... I see you didn't see that very well. So this is our dictionary. we're going to convert our input data, which is up here. Here, this is our input data. And so it's toy data, right? It's just a small amount of data. So this is our input data. What we're going to do is we're going to vectorize these words into numbers. So that way they match up with this dictionary lookup. We're tokenizing, right? We're tokenizing. Same with the tags. So that way, because AI likes numbers. And when you're throwing numbers into an embedding, it wants a token number, an ID, right? So instead of you doing your own one-hot encoding, when you typically do in a feed-forward neural network, we're only going to pass in the token ID. Same thing for our output on our negative log likelihood loss needs to happen here. And it wants IDs for the tokens on the output as well. So you can create a small language model using LSTM if you want your tokens to also be words on your output. In our case, our tokens are going to be classifications. So that's what we're doing here. Also, I think I deleted something by accident. I think I got rid of our activation. We did. Okay, so I need to add our activation back. Where's that at here? For soft. I need to bring that back. Bring our activation back here. So now we've got everything in line with the tutorial. However, instead of using the view, the weird view that they had there, we're just using unsqueeze, which is a lot easier. That's a lot easier to use. It's a lot easier, a lot quicker, right? Where did they have it here? So I think they were using this view. Where's that at? It was around here somewhere. Where's the forward method in our model? Here we go. Yeah, so they're using this view, the length of the sentence, and then you're subtracting. No, you're saying -1. So say which dimension that you want to target. And it's going to be the outer dimension, which means you want to grow the number of dimensions. Instead, just say unsqueeze. A lot easier. It's a lot easier, you guys. Okay. So now that we've got our output, everything's working good in our feed forward, we can start training the model. And then we're going to achieve our objective and we're good. And we finally beat it. So let's try our train now. Steven, you should upload your whole live sessions so we can go back and learn you in detail. Absolutely. In fact, we do. We've got all of them here. So just go Steven Blum on YouTube. You go to our lives and you can see right here. You can see our lives right here, you guys. Got all of our lives. So many different lives. So they're all available forever. So token could be anything basically, like classification or word or even things. Yes, exactly. They just got to be turned into numbers. That's awesome. Thanks. You're welcome. Sergio, you're welcome. Good to have you here. Okay, let's keep going, you guys, because we're almost done. We're almost to this part right here. We're almost to that part right there. So, we need to, for the number of epochs, we need to zero our grad inside of here. Let me just get rid of everything here. We need our delta. Print our delta and do back. Okay. Zero the grad, get the loss. Wait, before we do that though, don't we want to do that on the forward, which is here? Features, sentence. That'll be the input. Right? So labels. There's the label, the target. We'll call this tags. Tags and sentence. There we go. Our out will be the sentence. Sentence, thank you. We gotta spell things correctly. There we go. You've learned a lot watching. Nice, Anasazi! You make sense, you know? That's great to hear. That's great feedback. I appreciate it. Okay. So we got our tags, which is our target output labels. We got our sentences, which is our input data. And these are already tensors, and they are not pre-shaped in any way. We grabbed our output. We need to do model grad 0 here first. We're gonna get our criterion. We don't need to use index anymore. Or do we? Not on output. Just not on output. It's worth watching Steven. He knows how to break complex things down into easy digestibles. Hey, that's a great way to say it. Thank you. I appreciate it. This is good feedback. I like it. All right, we're almost done, you guys. Okay, I think we're good to go. Let me delete the stuff we don't use anymore. And this will train our model. If everything's in the right spot, it should work. If everything's in the right spot, it should work. Okay. So, I'm actually kind of curious, you guys. Where are we at here? 0. Let's reload that. I'm going to ask you guys a question. Here we go. Start a poll. All right. Success or fail? Will the model learn? Curious about that. Here we go, you guys. Okay. I think it will. I think it will, because we already proved that this part works here. The criterion should work because we're only targeting the sentence, right? Only one sentence at a time. We're going to tags here. Let's see, we can just do tags like this. Tags. Like that. I think we should be good to go. I think it's going to work, you guys. I think it's going to work. Long short-term memory. Yep. Yep, there we go. So where's the area to innovate with the LSTM? Long-term memory or short-term memory? The long short-term memory, right? Both. So this is the precursor to a transformer. A transformer is the current, as far as I know, state of the art. There's newer versions and stuff out there that people are experimenting with right now. Transformer is like ChatGPT, Anthropic, Gemini. They are the next level to an LSTM. They provide some of the similar benefits. The only thing is the LSTM only has attention for words in sequence. A transformer has attention for every input segment. So everything all at once, because it attends to everything. This is a new AI will be alive. It will? AGI? Transformers, Onyx, SQL. You're saying a whole bunch of things there, YOLO. What are you doing, Anasazi? Those SQL, one of those things isn't like the other. Something's out of order there. Okay, here we go. Let's see if it works, you guys. No errors. No errors. Oh, no. Only batches of spatial targets support 3D tensors, but got targets of dimension 1. Okay. So that's our tags here. Okay, so this part should work fine. Okay, good. Print out. Today you're using Word and wanted to see an image while writing. So, like everyone does, you vibe coded a Word add-in just to display images while writing? Wait, what do you mean? You made it work great. You wanted to publish it to the office. And you looked into it. You signed up. You needed a company or an ID, and you paid Microsoft for an account. So you gave up. You all got so far. You can't give up now, right? But people think LSTM has potential. Oh, do they? Well, it still has a purpose and meaning because it is still sequential analysis, and it is still used in the real world today. It's not like the state of the art for generative AI. It's state of the art for, classification, maybe, for attending in things in sequence. It's still worthwhile, and it's pretty efficient too. Don't want to give up your money to big Microsoft loons. Okay, we're really close, you guys. We're really close. I want to get my Delta working. The only thing is the tags. Oh, look at that. Our output is pretty embedded. That is a fairly embedded output there. Do we need to do anything with the output? Because that is a little bit out there. Did we go overboard on our unsqueezing? Let's see here. No, it has to be that. Okay. Wait, hold on. Okay, let's try this again. Unsqueeze. You feel like you heard people say that they still working on improving the LST method. Well, I can see that. I can see that. So that does work, but not really. because it gives us that. What happens if we reduce that down? Is that going to give us anything? It gives us zeros, basically. Okay. So we need to go back to this, which is going to give us our probabilities for each of the tags. The only thing is that our output is weird. Still the same shape. Let's try that. Nope, that won't work. Okay. Okay. So this means that we've got everything we need here. The problem is that I think we've got too many dimensions. So I think we need to squeeze this down on dimension 0, maybe? We'll find out. We'll find out. Okay. So this criterion is failing. Let's print the tags really quick. Oh, no, that's fine. That's fine. Oh, that's a problem. Okay. Target. Let's call it target. Here we go. See if we got. Let's see if we're on the right track here. Our targets look good. That looks fine to me. We get some good targets there. That's what negative likelihood loss wants it to be. Only batches of, but got a batch of dimension 1D. Is that for our targets or for our outputs? Only batches of spatial targets supported. It says targets. 3D tensor. So it needs to be unsqueezed as well? Are you sure? Let's try it. Let's try it. Its comprehension is high. SQL helps. So it fits in free space. 100 free to run. Strong enough to power any AI app. Okay. Unsqueeze it again to unsqueeze a second time. Do we need to unsqueeze it? Are we doing this properly? Like, no, it doesn't. I'm like, how's it going there, Prod by Core? Welcome on in. Happy Wednesday. Good to have you here. Let's see if we unsqueeze it again. Is that going to be enough? Is that what it wants? If that's what it wants. Try it. Now it is a 3D tensor. Expected input batch 7 to match target batch size 1. That should work. Here we go. Okay, where are we at now? Oh, okay. How about that? There we go. That's what it wants. Maybe. Let's see. Let's find out. Maybe. Maybe. Nope. Okay. Still no. Okay. All right. Expected input batch 7 to match target size batch of 1. But we made it better though. 1, not 0. I thought I saw it said batch size of 1. So it does say batch size of 1, but really, wait, expected input batch 7 to match target. So it still thinks that target is a batch of 1. Did we had it right? I mean, I thought we had it right before, because we did this. We did this earlier, and it was actually working. We actually had this successfully working. So what we could do is we could go check our GitHub really quick. Let's go here, GitHub. Go to our project repositories. Look for the tutorial. It's called LSTM. Where are we at here? LSTM full. Here we go. So here's our original. This was working before. Out index. What does our output look like? Yeah, this is 1. Do we need to unsqueeze our output, maybe? We might need to unsqueeze our output. Or we might need to squeeze our output. Only batches of spatial target 3D sense support. We've got a target of 2. Okay, so that solves that problem. And now we just need to figure out this right here. Okay. We're so close. This is like the last little bit. I know I always keep saying that. It's like the last little bit of the error here. It's just the smidgen of the last little bit of the error. Okay. It matches the shape, I think. So it says 1, 2, 3, right? Although this is 4. 1, 2, 3, 4. So that seems like it's a bit much, right? It seems like it's a little bit extra. SQUEEZE 0. See what that looks like. So now, oh, that didn't do what I wanted it to do. Let's try 1. There we go. Okay. Now they look similar in size. Unsqueeze 1. Which would be very weird. Okay. Expected input batch 7. What if we go back to... No, it doesn't make any sense though. Yeah, now we got to a point where it's like, what do we do from here? We're just trying to use negative likelihood loss. That's what we're trying to do. This tutorial is crazy. I know, it's a crazy one. It is crazy. It's like, oh, look, it works perfectly fine. So we get our sentence and our tags. And I have everything that's correct here. And then we get our output from the model. And this is where we're failing right now. The loss function is negative log likelihood. Yep, right here. Negative log likelihood loss. And it's not doing anything special, right? It's just running it through and it's getting these standard outputs. So why don't we try that then? Let's see here. For sentence and tags, that's what we have here. Training data. Okay, so it prepares the training data inside of the... Got it. Where are we at here? And I'm just grabbing those here instead of enumerating, I'm grabbing them here like this. Target, sentence, labels, tensor, looks good. And then we're grabbing the target and the sentence. Print, target, and sentence. I'm just gonna make sure that it looks correct. Okay. So where are we at here? Okay, so, oh. No, that's fine. I think that's correct. Okay. Does this need to be a... like that? No. Do we need to put the input? Does the input need to be different? We're so close, you guys. We're so close. We might have to do this tomorrow. We might, because we have like 6 minutes left. Okay, we got 6 minutes here. Can we do this in 6 minutes? I don't know. Tag, sentence, features. All right. Sentence right here. All right. What if we just put in the full... No, that won't do the trick. What if we just say labels? I'm just gonna try something. I don't think it's gonna work. Okay, it did. Crossing fingers. Yeah, I get the video generator is being built. Feel good about it. You wrote it. It's very good. Waiting for an AI team design and the weights. Live video 2 megabytes code to build it. The music is sedating. Do you want me to change it, Joshua? I can change it. There you go. That's like calming. Maybe a little bit more calming. Since and links equals 7, but it's expecting 1. What? I know, right, Kyle's like, what's going on? And now it says 3. Expected input batch size 7 match the target size 3. And here's the thing, it is the same. Like I'm printing them out right here. Although print target. It's great. I'm kidding. Oh, hey, no worries, Joshua. Wait, let me know. Let me know if anything we could change. All right, so I want to see why this is failing. Return. I'm trying to understand it, really. So we've got our features and labels. Looks good to me. All fancy and good. Features at the right, labels at the right. And we've got our output here. And what are our targets? So there's 4 words. Oh. Yes, that's correct. Okay, so that's correct. The output is just so densely packed is the thing. Did it always used to look like that? I don't think it did. It's just such a massive output. But it seems to be okay. Huh. Okay. Well, output target. And that's going to fail again. Only batches of spatial target supported, but got target of dimension 1. Yeah, because that's the way it was before. And that's also what they're using here in the tutorial. All right. So what we're going to have to do is we're probably going to have to do this tomorrow. So we need to debug this. This part right here is broken, and I'm kind of stuck on it right now. And it's like really, the framework is kind of restrictive, right? A lot of what I've done when I've been building with this framework is building it like I would when I would build it myself from scratch. However, the framework is very much expecting very specific inputs. And in this case, the negative log likelihood loss wants some sort of parity here. And the good news is they are 7. It is a batch of 7 on both sides. It just needs to be the right shape. Sorry, I gotta go sleep. All right, sounds 11 p.m. Sounds good, Loons. It was so good to have you here. I'm gonna, we're kind of like on the last legs here. We are headed out as well here pretty soon. Input 711. Oh, target 711. Okay, size mismatch. See, this is weird. This part's weird. Is that what we're expecting? Instead of, maybe our problem here is that we're using unsqueeze when we need to be using view. So let's try this. We'll try this instead. Do you work at home? Yes, I do. I sure do, Mark Lemon. Or do you go into the office every day? Work at home. All right, Loons, it's good to see ya. See you tomorrow, hopefully. Since yesterday, you've been working on the Python basics, creating lists and difference between a tuple and a list. Hey, the tuples! All right. So we're gonna try this. We're gonna try updating instead of unsqueezing. We're gonna try this. What was this? View on the embeds. Okay. We'll try that. And it's the same below, right? It's going to give me the same thing, though. It's going to give me the same thing. It didn't. It didn't give me the same. Well, no, it gave me an error. Okay. Zero. Yes. Okay, there we go. I see what's going on. All right, so sentence zero. Yeah, there we go. Thank you for the party poppers. Appreciate it. We're gonna call this sentence. Okay, good. Good to have you guys here. Happy Wednesday. All right, so laying of a 0D tensor. All right. So now, oh, it did change. It changed. It's not the same as unsqueeze. I thought it was. It is different. Interesting. Interesting, you guys. So the view actually changes it differently. Okay. I thought we were being fancy. Seven, 4, got 7. What's the last 4 of your social? I know, right, Kyle? Since yesterday, okay. This song is kind of cool, though. It's like yeah, I like it. It's pretty good. It's a good one. Okay. So we're right here. 7... Expected target size 7.4, but got 7. That looks a lot better, by the way. Okay. So we're really close. I'm going to commit this now, and we got to get going, though. Good. Thank you for the party poppers. Wrong shape, right? It is. Yep, we got the wrong shape. And how to make it 4? Don't. Is it looking for? It really is looking for 1 hot. We did that originally. We originally did that. We could make it. We 100% could do that. We could do that. We know how to do that. We can fix that right now. So let's do it. Let's do it. All right. So negative likelihood of loss. Apparently, you want the way that I wanted it in the first place, which is right here, I think. The old labels. So we just change this. See, this is the new labels. I think we just go back to that, right? And we need to tag mask instead of 0. There we go. Okay. Target 1 is output out of bounds? What do you mean? No, it's not out of bounds. It certainly is not. All right, target 1 is out of bounds. This is incorrect. Okay, so yes, it is out of bounds. Let's see here. It should be not tagged. It should be not this. It needs to be a 1 or a 0. Right, let me see here. Let's try that. You're like brute forcing this. I know I am. We're really close. All right, so this song's really good. Thank you for the party poppers. We're getting close. We're getting close. If Lin Y. Oh, this is for the mask, which is working. We got the mask working, and then we need to get the actual value. So if tag and we get the value, or set it to mask. So we need to keep the mask. And the mask is going to be 3, I believe. So we need to keep that. So let's see if we get our mask back. The mask is still not back. Oh, because it's always 1. Okay, so we can't do that. This is always 1. So what we need to do is... So let me just bring that back really quick. Alright, so we get the 3, but it's also being 0 here again, and it needs to be... Where's 0 coming in? How's it going there? AI with Buyer. Welcome on in, AI with Buyer. Good to have you here. Happy Wednesday. Alright, so we're currently becoming Pytorch experts, although we're struggling, which is part of the journey. In order to learn, you gotta go through the struggle. I like this one. Reminds me of Sonic. It kind of does, doesn't it? Sega. A little bit of Sega adventure there. All right. So we need... So it is... Oh, wait. Hold on. I was looking in the wrong spot. Oh, well, I mean, I wasn't really. This also counts right here. So this will be the right shape because it's giving it 4. The only thing is it needs to be 1 hot. So only one of these needs to be a 0. So if T... See, we need to do this. Like that. We need to do this. Equals T. Is equal to T. There we go. Let's try that. Let's see if that works. It worked. There it is, right there. That's what I'm looking for. All right. So now we one-hotted it, the original thing that we did at the beginning of time. So now that it's 1 hot, let's see if our model will work here. Let's see here. Model out, sentence print. Let's see, everything is good there. Okay. So now we've one-hotted it. It's the correct shape now, as far as I can tell. It's one-hotted. And we've got our padding. Criterion. Target. So here's our target. And here's our output. So this before this, so obviously this isn't working right now. However, print. Dot shape. There we go. 74714. Does it need to be the same? Huh. So I think, what is it? The shape on the target is just off. We need to add a dimension into it at the. What is this? What would that look like? So 417. We have to add an extra wrapper around it. Is that what it's doing? What are you masking? Hey Dylan, how's it going? We're just a pad. It's just the pad. So whenever we have input window size, right? And it has, you set the limit on the dimension on the input window for the sequence. And some of our sentences don't use up the full sequence. So we have to throw padding in there. Hey Nike, what's going on? Good to have you here. Happy Wednesday. We got Nike here, you guys. Hi. What are you making? We're doing an LSTM, long short-term memory model. Currently, we're trying to get the shapes correctly so that way we can do our criterion, our loss, so we can calculate our gradients and then train the model. And we're just inches away from it finishing. We're just inches away. We had it working a few days ago, and then we changed it all up because we felt like it, and we got ourselves into a place where it stopped working. However, now that I see our targets need to be the right shape, our output is very odd from our model. Do we want to change that? Let me see here. Dims 1. Here we go. Oh. Here we go, 1. Let's take a look at it now. Let's see, take a look at it now. No, it didn't do anything. Hold on. 0? Does it need to be 1? It says 1 here. This is our tag space. Okay, and then we need to run a forward on that. How do you learn all of this? Dylan, what we did was we went through a lot of the tutorials. And right now we're at a place where we basically went through the full tutorial and we sped run it. We did a speed run. Most of the time we spent on preparing the data. We're gonna prepare the data. That's just what you gotta do. AI is mostly data preparation. The model is actually pretty short. As you can see right here, this is the whole model basically. It fits onto one screen. And as you can tell, there's only like 12 lines of code. It's not a lot. It's not a lot of lines of code. However, if you measure the whole file, it's 148 lines of code. So the rest of that file is data manipulation. That's what we're currently dealing with. Story of your life, Kyle, is it? Oh, wow. Okay. So let me continue here. I am out of time. I do got to get going. I'm pretty sure. Let me make sure I'm not missing anything, because I will have to run otherwise. I think we're okay. Yeah, we're fine. We're fine. Though I do have other things that I got to take care of today, so I do have to get going pretty soon. However, I have a few more moments. Onik, what's wrong with Transformers? I don't know why it said that. Oh, I'm not sure why either, Anasazi. Lot of lines. Yep, you're right, Joshua. Is the story of your life? It is. It's the story of your life. A lot of lines of code. You're working on a system right now, and your words got crossed. Oh, Anasazi. That can happen. I can see how it can happen. Thank you for the reactions, you guys. Good to have you here. You make it all the better that you guys are here. It's all the better. It's all the better. Thank you for being here. Okay. So this is where we need to figure this out. So does all targets and output shapes need to be the same? Or will it start working? Let's try it. Let's see. I don't know if it will or not. See, so target 1 is out of bounds. What is target 1? Target 1 is out of bounds? What do you mean it's out of bounds? It's the shape that you asked for. You're like, it's got to be in this shape. Okay, so let's go up here. Let's see what we got here. What's our output? Okay. We got our features, our labels. Looking good. Let's go with this. Let's make it a little bit easier on ourselves so we don't print out everything all at once. Let's only print out these guys here. Let's get rid of these. We vectorize. Do you know how to make games? Also, I do, Dylan. We did that before in this channel. We made a game. Not a very good one. It wasn't very good. It was a lot of fun though. We had it working earlier, and then we rewrote it, and it's broken. The story of your life. That is the story of your life right there. Exactly. It was working, and then I rewrote it. Not working anymore. Not working anymore. Okay. I want to see why that's failing. We're gonna print let's gonna print this out here. I'm gonna make this a little bit easier to see. Okay, so we can see it. He made a game on stream. I did. It was live on stream, you guys. It was live on stream. Okay, so here's our output. Oh, look at that. That's broken right there, as you can see. A little bit of a broken output. We can fix that. Dim. Here we go. 0. Do you have tips for learning Python? Yes, go to the Python website. Python.org. Click on docs. Look for beginner's guide. There's also non-English docs. If you want some non-English docs, then there's a beginner's guide. Click on those. You're good to go. Easy, easy. Just go straight to the source. Jason Williams. You gotta go straight to the source, Jason Williams. Okay. Thank you. You're welcome. Is our output looking better now? Yes, it is. Okay. Now we've got correct output. We got our size. So I see there's like an extra dimension in there. It just for what reason? Why? Why is there an extra dimension? Like it doesn't make any sense. Why is there an extra dimension? So how many things can you make with Python? Basically anything. Except for a mobile app. That's the only thing you can't make with Python. There is a framework that I think is available for you to use Python to write a mobile app. However, you're typically going to do something different. You want to use Kotlin, multi-platform, or you could use, Swift, which also has a multi-platform now, right? Android and iOS. You could use Unity, or there's a couple other C# out there. You could use React Native. Python doesn't do the mobileware. You think setting specific goals for projects and milestones are good practice, so as a dev, you don't overdo it or overthink projects. Yeah, exactly. Exactly. I agree with you on that. You got to have that target goal. You got to time box it so that way you're right in the right amount of time. You don't want to go too far, because that's what we did today and we broke it. We went too far, you guys. We went too far and we broke it. Okay. Target 1 is out of bounds. Do we want to make our target a different shape? We could. We could double up on it. We could unsqueeze our target. What if we did that? Let's see if we make our targets identical to our outputs, or we could squeeze our out. Squeeze 1. Let's try it. Out equals out dot squeeze. Let's try that. Let's see what that looks like, you guys. How's it going there? Caleb Holt, good to see you. Good to have you in. Dylan, bro, you're amazing. You are. Hey, it's good to hear. It's good positive feedback for yourself. Enter a name. All right. How are you? What are you trying to do? How's it going? Enter a name. Good to have you here. Happy Wednesday. We're becoming Pytorch experts. We're learning all of Pytorch. Today, we're building an LSTM, a long short-term memory model, and we're currently dealing with data. We're stuck in a little spot right now. We're trying to debug it. That's what we're doing right now. Do you use Vim to code? I sure do. Enter a name. Yes, I do. This is Vim. Vim plus tmux plus ghosty. That's what we're using. And I use it for everything. What? Hey, walk in beauty. Good to see ya. Welcome on in. All right, let's see if we got here. Okay, our target looks like that. And our unsqueeze looks like that. Yeah, see? Now they're the same shape. They're the same shape now, you guys. Should have worked. They're 7.4 by 7.4. You think it'll work now? You think it'll work? Do you think it'll work? Walk in a beauty what? My dog's name is amazing. Oh, is it? Oh, Dylan, really? No idea what you're talking about? Hey, no worries. We're software engineering. We're building AI. If you use ChatGPT, that's what we're building. That's what we're building. Hey, that's what we're doing. All right, so we're really close. So let's see if now that we've identified the full shapes, it's gonna work this time now. Is it gonna work? I don't know, we're gonna find out. Still 0D or 1D target tensor expected, multi-target not supported. Okay. I think I know what we need to do here. See, this is old, the new. Right? Right, you guys, right, there we go. There we did it. Okay, thank you. Oh my goodness, finally. It only took us like 2 weeks. Nice, yeah. I might go back to making small code projects for beginners and make videos like I used to with unique UX. Kyle, that sounds like a lot of fun. It's really great. If you're using Linux, that's incredible. All my esteem. Hey, yep, we're using a Unix-based system. Uname right here. I don't know if you can see it on screen. Uname right there. A little bit of Uname, if you're familiar. Okay, so it was the way we learned it over the last couple of days. Negative log likelihood loss it does want, it really does want the tokens. It doesn't want the one hot. Isn't that crazy? It's like, it went back and forth. I'm like, no, it really wants the one hot. No, it wants the tokens. You have white matter disaster. Oh no, thinking is above your head. Oh, at the moment, seriously, walking beauty. Well, you can the stream chat will do the thinking for you. We'll do the thinking for you. No worries, no worries. I'm so happy. All right, we did it, you guys. Thank goodness. Okay. All right, back propagation time. Back propagation time, you guys. Here we go. Delta dot backward and optimize. Let's see if it works. Let's see if it works. Moment of truth. Here we go, you guys. It worked. It worked. We did it. We did it, everybody. Good job. We did it. Oh, you know what? Oh, you know what? Can we go to the next? Yes, we can. Let's do the next one. We're going to the next one, you guys. We're going to the next one. How about this? I'm looking for a good song. How about this one? This is fine. This is fine. All right, we did it, you guys. Congrats, we did it, Kyle. We did it. All right, let me commit this. Get status, get add, get commit am. We did it. Dash m success. We did it. All right, so tomorrow, now that we've trained the model, we're going to test it. More than a sailing Boston. We're good to go. You wish you could get it? Okay, no worries. Hey, chat's gonna help. Feeling more than a Boston, more than a sailing Boston. I've never heard that term. I don't know what that means. What does that mean? A walk in beauty? What does that mean? I feel like you would have built this faster with the tutorial, without the tutorial. We might have, yeah. Hi again, Raked. How's it going there, Raked? Good to have you here. Welcome on in. All right, so we did it. We succeeded. We did it. All right, pop the poppers. Here we go. Push. Boom. Off to GitHub. Thank goodness. All right, I knew we'd get it eventually. I knew we'd get it eventually. So let's increase the epochs and print out the loss. All right, so let's do print. We'll do delta.item. And this will be the loss. And we need to, we'll do that per epoch. So we'll print that here. Oh, wait, no, we can't. We'll do it inside. Not a big deal, And we'll set the epochs to a higher number so we can train there. And it should start reducing. Let's do 1,000. Here, wrong button. Get. There we go. Thanks for the hearts, you guys. It worked. Look, you guys, it went below 1. Oh, look at that. Okay, where is it at? All right, so 1,000's too many. Let's do 10. Let's do 10. Yep. We did it. Oh, look at that. This is fantastic. It only took us 2 weeks. Oh my goodness, there we go, you guys. We did it. Hey, Soki, how's it going? I did some LLM tasks today for class using async and await. Nice. And your colleagues waited 2 hours. You did it in 4 minutes. You did? No way. That's awesome. We did it with training, guys. We succeeded. Okay, so tomorrow, the plan for tomorrow is we're going to play around with this. We're going to make fun with this. We're going to have a lot of fun. So we'll start messing with it and seeing that it gets what the accuracy. We see that it's learning because the loss reduces below 1. You can see these numbers are below 1, which is fantastic. It's amazing. The learning rate seems a little high to me. I think we can bump that down a smidge and add some more. There we go. Yeah, there we go. Nice. That's what we're looking for there. We did it. What's your favorite optimizer? SGD. I would say SGD is nice because it's really smooth, right? It's going to give you the smoothest. It always smooths everything out. RMS prop is fine for certain scenarios. However, Atom W is going to give you the fastest training, so lower compute. Usually Atom W, right? Soki, Atom W. SGD though, I like SGD. I think it's my favorite. It's because this is the first one I ever used. Because I wrote from scratch. My first model used SGD. But isn't SGD too vague? It's very vague. It's purposefully vague. It's purposely vague. It smooths everything out nicely, and I like smooth. I do. I like it smooth. We did it, you guys. Okay. So it was really good to have you guys here. I do have to get going. I had a lot of fun today. Tomorrow, what we're going to do is more LSTM, and we're going to be messing around with it now that we've got it working. Git status. Git add. I'm gonna commit again. Git commit. We updated hypers with a lower LR. There we go. Push it to the main. Boom. Off to the race. All right, guys, had a lot of fun. We'll be back tomorrow. Enjoyed spending time with you. Tomorrow, more LSTM, more Pytorch. Bye, everybody. Have a good one. Enjoy the rest of your day. See you, everybody. Thank you for the hearts. Thank you for the reactions. Good to have you here. Bye, guys. See you tomorrow.